And in our last story this hour, China is on an unprecedented journey to explore the dark side of the moon. And we could see new data from the mission very soon.
For decades, the moon was treated as a completed mission. Humanity went there, studied it, and moved on. But that perception is starting to change. Today, global attention is returning to the moon, not because of history, but because of one specific region that is becoming critically important: the Earku. This area is not valuable for symbolic reasons. It is valuable because of what exists there. Deep within craters that never receive sunlight, where temperatures remain extremely low, scientists have found strong evidence of frozen water. These permanently shadowed regions have preserved ice for billions of years. And in the context of space exploration, water is not just useful, it is essential. Water can be processed into oxygen and hydrogen. Oxygen supports human life, while hydrogen can be used as rocket fuel. This transforms the moon from a simple destination into a functional part of space operations. Instead of relying entirely on Earth, future missions could use the moon as a supply point, reducing costs and enabling longer and more complex missions deeper into space. What makes the South Pole even more significant is the presence of nearby mannatic that receive near-continuous sunlight. These areas can provide a stable source of energy, creating a rare combination of water and power in the same region. In space, this combination is extremely limited, which is why this location is now a primary target. Multiple countries are now focusing on the same region, not because it is easy to access, but because it offers long-term strategic advantages. This is no longer about repeating past achievements. It is about securing a position in a location that could define the future of space exploration. Control over this region means access to water. Access to water means the ability to produce fuel. And in space, fuel determines mobility. The ability to move, operate, and expand beyond Earth depends on these resources. The moon is no longer just a place humanity once visited. It is becoming a strategic nukta that could influence the balance of power beyond Earth. And at the center of this shift is a region defined by darkness, extreme conditions, and resources that could determine who gains the advantage in the next phase of space exploration. Whoever controls this area controls access to deep space. While multiple nations are now focusing on the moon's most strategic region, one country has been moving toward this moment for a long time, quietly, consistently, and without relying on global attention. China is not the first country to reach the moon, and it was never the fastest to get there. But speed was never the objective. What sets China apart is not a single breakthrough, but the pattern behind its progress. Instead of rushing into high-risk missions or competing for headlines, its approach has been structured and deliberate. Each step has been planned in advance, executed with precision, and built on top of the previous one. There are no sudden leaps, no unpredictable shifts, just a steady expansion of capability over time. This approach is often less visible, but far more stable. While other space programs face delays, budget shifts, and changing priorities, China's trajectory has remained largely consistent. The focus has not been on proving something quickly, but on building something that can last. And that difference matters, especially in an environment like space, where long-term planning defines success. China's lunar efforts are part of a broader system, not isolated missions. Every launch, every landing, every piece of data collected is part of a larger objective that has been developing for years. This creates a level of continuity that is difficult to replicate. Instead of reacting to competition, the program moves according to its own timeline. From the outside, this can appear less dramatic. There are fewer public narratives, fewer high-profile announcements, and less emphasis on global perception. But underneath that, there is a clear direction. The goal is not just to reach the moon again, but to build the capability to operate there repeatedly, reliably, and eventually permanently. This is why China's presence in the current lunar race feels different. It is not defined by urgency, but by control. not by speed, but by consistency. And in a long-term competition, where timelines stretch across decades, that kind of approach can become a decisive advantage. Because in this phase of space exploration, the country that succeeds may not be the one that moves first. It may be the one that never stops moving forward. What makes this progression more significant is that it was never random. Behind it is a long-term system known as the Chinese Lunar Exploration Program, a program that was designed from the beginning to move in stages, each one preparing for the next. It did not begin with landings or bold demonstrations. It began quietly, in orbit. Early missions focused on mapping the moon in high detail, building a complete understanding of its surface, its terrain, and its potential landing zones. This phase was not meant to attract attention. It was meant to reduce uncertainty. Before attempting anything complex, the objective was simple: know the environment completely. Once that foundation was established, the next step followed naturally. Landing on the moon was no longer a question of possibility, but execution. The missions that followed were not experimental in the traditional sense. They were controlled, calculated, and designed to prove that China could operate on the lunar surface with precision. Navigation, landing stability, surface mobility. Each capability was tested and refined in sequence. Then came the next shift. It was no longer enough to land and operate. The objective expanded to retrieval. Bringing material back from the moon requires a completely different level of coordination. Launching from Earth, landing, collecting samples, launching again from the moon, and safely returning to Earth. This is not a single achievement. It is a chain of systems working together without failure. And once that chain works, it changes what is possible. At that point, the direction becomes clear. Orbiting leads to landing. Landing leads to operating. Operating leads to returning. And returning leads to something more permanent. Because once a program can repeatedly reach the moon, land accurately, function on the surface, and transport material back and forth, the next logical step is no longer temporary missions. It is presence. This is where the strategy reveals itself. None of these missions were isolated achievements. They were not designed to stand alone or to mark a single moment of success. Each one was a preparation step, reducing risk, increasing capability, and building toward a long-term objective that extends beyond short visits. From the outside, these missions can look like milestones, but in reality, they were never endpoints. They were setups. And now, after years of building those capabilities step by step, the transition is already underway. For a long time, the moon was considered predictable. After the Apollo missions led by NASA, the general understanding was that the moon was geologically inactive, a place shaped by ancient events, but no longer changing. It was seen as stable, silent, and largely understood. That assumption started to shift with a mission that, at first, did not seem designed to challenge anything. When Chang'e 3 successfully reached the lunar surface, it deployed a rover known as U2. The mission itself was seen as a demonstration of capability, proof that China could land and operate on the moon. But what it found carried a different kind of significance. As the rover moved across the surface and analyzed the surrounding material, it identified something unexpected. The composition of the rocks did not fully match what had been collected during earlier missions. These were not just variations of what was already known. They pointed to a different geological history, one that suggested volcanic activity on the moon may have lasted longer than previously believed. This detail may seem subtle, but its implications are not, because it means the model that had shaped scientific understanding for decades may have been incomplete. The moon was not as simple as it appeared. It was not as finished as it was once described, and that changes how future missions are approached. If the moon's geological history is more complex, then its surface may hold more variation than expected. Different regions may contain different materials, formed under different conditions, at different times. That increases both the scientific value and the strategic importance of continued exploration. This is where the significance of the mission becomes clear. It was not just about proving that China could reach the moon. It was about revealing that there was still more to discover, more than what had already been studied decades earlier. The moon, once seen as a closed chapter, started to look open again. Not fully understood, not fully explored, and not as dead as it once seemed. There is one part of the moon that never faces Earth. No matter how advanced our telescopes are, no matter how long we observe it, this region remains permanently out of direct view. It is often referred to as the far side. A place defined not just by distance, but by isolation. For decades, reaching this area was considered extremely difficult, not because of landing itself, but because of communication. Any spacecraft operating there would immediately lose direct contact with Earth. No signals could pass through the moon, no real-time control, no constant data stream. Without a solution to that problem, operating on the far side was simply not practical. That changed with Chang'e 4. Instead of avoiding the limitation, the mission was designed around it. Before attempting the landing, China deployed a relay satellite into a precise position in space, far enough to maintain constant line of sight with both Earth and the far side of the moon. This satellite became the link, allowing signals to travel where they previously could not. Only after that system was in place did the mission proceed. The landing itself was not just another milestone. It was the first successful operation on a part of the moon that had never been directly explored on the surface before. A region that, until that moment, existed mostly as a concept rather than an accessible environment. And once the rover began operating, the significance became clear. This was not just about reaching a new location. It was about proving that complex operations could be sustained in conditions where direct control was no longer possible. Delayed communication, reliance on relay systems, and limited visibility. These are the same challenges that define deeper space missions. In other words, this was not just a lunar mission, it was a test for operating beyond the moon. From a technical perspective, it demonstrated a level of coordination that goes beyond landing and exploration. It showed that infrastructure could be built in space to support operations in otherwise unreachable environments. And once that capability exists, the definition of accessible begins to change. Because the far side of the moon was never just another destination. It was a barrier. And that barrier is no longer there. They did not choose the easiest place to land. They chose the one that required solving a problem no one else had fully overcome. They went where no one else could operate. And they made it work. The next phase of lunar exploration is not just about going back. It is about going further into places that were previously considered inaccessible. And this is where the strategy begins to move into a different level entirely. The focus returns to the most extreme parts of the moon, deep craters near the South Pole, where sunlight never reaches and conditions remain permanently hostile. These monadic are not just difficult to explore. They are environments where traditional systems begin to fail. Temperatures drop to levels that can disable standard equipment. Visibility is limited, and terrain becomes unpredictable. This is where the upcoming Chang'e 7 mission introduces something fundamentally different. Instead of relying only on wheeled rovers, which are limited by slopes and obstacles, this mission is expected to deploy a new type of robotic system, one that can move by hopping across the surface. This may seem like a small change, but in an environment filled with steep crater walls and uneven terrain, mobility becomes the defining factor between access and limitation. A wheeled rover can only go so far. A system designed to jump can go where wheels cannot. This is not just a design upgrade. It is a shift in how exploration is approached. Instead of adapting the environment to fit existing technology, the technology itself is being redesigned to match the environment. That difference allows missions to reach deeper, darker, and more unstable regions that were previously out of reach. And those regions matter, because inside those permanently shadowed craters lies the very resource that has reshaped the importance of the moon: water ice. Accessing it is not straightforward. It requires entering areas that are not only difficult to navigate, but also impossible for humans to operate in directly without extensive support systems. This is why the focus is no longer just on sending humans. It is about preparing machines that can go ahead of them. Machines that can survive where humans cannot. Machines that can explore analyze, and operate independently in extreme conditions. Machines that reduce risk while expanding reach. This approach reflects a deeper shift in strategy. The goal is no longer limited to exploration under controlled conditions. It is expanding into environments that push the limits of both engineering and planning. Because if these systems can operate in the harshest parts of the Moon, then the range of what is considered possible begins to expand as well. The mission is not just about gathering data. It is about proving that even the most hostile regions are no longer out of reach. They are designing machines for places humans can't survive. And once those places become accessible, the map of the Moon changes again. What is happening on the Moon right now is not a distant plan anymore. It is already in motion. Step by step, capability by capability, the foundation is being built. From securing access to critical resources at the Moon's South Pole, to developing systems that can operate in extreme conditions, the direction is becoming clearer. This is no longer just about reaching the Moon. It is about learning how to operate there under any condition, in any environment. And once that capability is fully established, the next step becomes inevitable. Because in space, the ability to operate leads to the ability to stay. And the ability to stay changes everything. The question is no longer who can reach the Moon. It is who will be ready to remain there when it matters most. Because what is being built today will not just define the future of space exploration. It will define who leads it.